PDF here. So first, I'm just going to read through the 7 questions that you need to answer, and then I will show you how to do them. I'll give you an example. Okay, so here's a bunch of information. Hopefully you've read it. I'm not going to go through it right now, but please read it. Excellent. So here are the questions you need to answer in your report. Number 1, for each star for which you can see the peak in the continuum spectrum, use Wien's law to calculate its temperature. So we will go over how to do that. Number 2 is sort the stars based on their temperature. So you guys only have 2 stars because I tried to make your lives easy. So just tell me which one's hotter, which one's colder. This is a really easy question. Based on the emission and absorption lines, you identified and the information in the classification table, assign a spectral class to each star. So what we're going to do is we're going to take a look at that spectral classification table, and then using the temperature and the emission and absorption lines, we can assign a spectra. That will make more sense when I get there. Number 4, list your stars from coldest to hottest again. So because I'm only showing you one example, 2 and 4 I'm kind of going to skip over, but I think they're pretty self-explanatory. Okay, number 5 through 7 I'm happy to take questions about, but these are really for you guys to think about. So I'm not going to just give you the answers to these. 5 through 7 you only need to answer once. You don't need to answer it for both stars. But number 5 is, aw, so cute. These are real stars, and like people, each star is special and unique. Some of these stars have characteristics which makes them deviate from the classifications given. For the stars which deviate, describe how they do not match the description of their spectral class. And then do any of the stars not match their spectral class. So that's one for you guys to just think about on your own, answer. I would like 4 or more sentences, I would say. So it should be more than just one word. Shoot for like a short paragraph for number 5. Number 6, we know the absorption lines in a star's spectrum are caused by its cooler atmosphere, but some of these stars also have emission lines. Describe a physical scenario in which a star's spectrum will contain emission lines. And then this does not have to be the right explanation for the stars that you chose. So this one is probably the trickiest one because this final project hopefully is pretty straightforward. I'm not going to give you too many hints on this. I really want you to think about it. Again, looking for a short paragraph, so 4 or more sentences. Okay, and then number 7, this one is just for fun. So this one is create your own mnemonic for the spectral class sequence. So this is really easy. It's not supposed to be a high work or stressful question. I'll show you an example that I came up with in a sec, but yeah, this is just for fun, so we'll go through that later. Any questions about any of the questions? Okay, great. Okay, so like I said, I'm just gonna show you what I would do if I were given this. So the first thing I would do, I don't remember what Wien's law is. I'm gonna Google Wien's law. I actually do, by the way, but pretending that I don't. Wien's law, astronomy. Wikipedia is awesome for astronomy, by the way, and physics in general. It generally, sorry, I'm not doing anything. Okay, so here is Wien's law. Lambda equals b over t. So what we're going to do, I wish it were easier for me to put the screen up and down, but maybe I can open a little Word doc here. I should have thought of this because I wanted to write on the board, but then I would have to lower and raise the screen all the time. How do I use a PC? Hello? Anybody know how to use a PC? How do I find a Word doc?
Just type in Word.
Over here?
You can just type in Word.
Oh, nice. Thank you.
Yeah.
I feel like people who have Macs are like crippled. Okay. So this is number 1. You should actually be writing more than I'm going to write here. I'm just going to kind of take some short notes. But going back over here, number 1, we have a lambda p equals b over t.
character? Yeah, I'll do that one. If you want. You're lucky I even put
Okay,
that
so
in
what we
there.
want to do
Okay.
is we want to find the temperature of each star given our lambda peak. So I will show you how to do that within the application for your final project. But first, we need to solve for T because the temperature is what we're looking for each of these stars. So let me know if I'm going too fast on the math here. But what we can do is we can multiply T on both sides. I'm just going to use L for lambda equals B. And then T equals B over L. Straightforward? Everybody good? Then going back to the Wikipedia, we can find what B actually is. B is a constant. It's Wien's displacement constant. And that is going to be this 2 point blah, blah, blah times 10 to the minus 3. So I'm going to just copy that, put it in my Word document. So B equals please. Okay, there we go. Great. We don't need so many decimal places. We can save like 3 or so. I feel like in college science classes, they're really big on significant figures, and in fields like chemistry, it's more important. At least in my field of physics, we don't really care. Save a couple. Like, get it as accurate as you want. Okay. And then there's an important thing to note on this equation. So B is in meters times Kelvin. So that's going to come in handy later. So that means our temperature needs to be in kelvins, and our wavelength needs to be in meters. So we might have to do a little conversion there. Okay, cool. Okay, so tackling number 1. Now we need to actually find our stellar spectra. So at the top of this PDF, there's a link here. It's going to take you to this application that was created in like, I don't know, 2003. But it works fine. So this is a little bit intimidating, but actually it is pretty straightforward to use. All we need to do is, for each of your stars, you are going to go to this KPNO archive. You're going to pick a star. I'm going to pick GB 1606. For your final presentation, please say clearly which stars you are analyzing. So for this one, you would be analyzing GB 1606, which is now on the top of the plot there and in that little drop-down box. Okay, so for GB 1606, what I like to do is I like to click this box that says all metals and molecules. So this is going to tell me what my different absorption lines are corresponding to. So we have here some calcium, magnesium, iron, sodium, titanium oxide. We can click on the hydrogen to see the hydrogen. We can click on the helium to see the helium. But for number 1, you actually don't need to worry about any of that. For number 1, all you want to figure out is what is the top peak. We're looking for the peak wavelength. So what is the highest point on this plot in the green line? And the way that we figure out exactly what this point is, so this is going to be my highest point. I can just look by eye and see that, or maybe it's this over here. I think it actually might be that over there at the very bottom there. Okay. Yes, and we can kind of use this grid and see that, yes, this one over here is actually the tallest. So what we want to do is we want to figure out exactly what wavelength this peak frequency corresponds to, or peak wavelength. So what I'm going to do, okay, so the clicker thing is like a little weird, but what I'm trying to do is I'm trying to use these arrows and get this little orange dot down to that peak in the flux density. So, it's kind of weird. I would recommend using the little arrows. For this one, I actually picked kind of a weird example here, which is fine. But when you have to get all the way over to the edge of the plot, it's like a little difficult. But we can do it. Please. know what? This is a weird star. Don't pick this star. I'm going to show you an easier one. the tool gets a little buggy if you're trying to get all the way over to the edge. So I'm going to pick a different star. So sorry about that. I should have seen that before. But now you can see a second example. Okay, so let's try this one. Cool. Wow, look at that. That's a great peak. So you can see the peak in our flux density is right there. It's going to be somewhere in between 4,500 and 5,000. And now I'm going to do the same thing, and hopefully, yes, look how well that works out. I'm going to go up to my, oops, so that's the line, so this is a little bit tricky. So now that this peak is inside that little orange bubble, then I'm going to come down here. You should ignore this temperature. This is this system's own calculation of the temperature. That is not the temperature you are calculating. The temperature you're calculating, you're using Wien's law to calculate, using this peak lambda. So this is what we care about here.
That's an angstrom.
So this is in angstroms. As you can see, this corresponds to this point down here. It is 4681 angstroms. So L equals 4.61. Was that right? No. I don't know where I got that. 4681. 4681 angstroms. Anybody know what I need to do next to calculate the temperature?
Convert it.
Exactly, yeah, we need to convert it. So our wavelength needs to be in meters, not angstroms. So the way to do this is to go back to your browser, Google, it's really hard to type in front of an audience. I don't know if you guys know that. Convert angstroms to
Nah, you don't need to. Just memorize it.
meters.
Why would you do that?
And here we go. We can just use this. So that was, again, 4681 angstroms. Okay, so we get now 4.681 times 10 to the minus 7 meters. Copy that. Oops. All right, and now we can plug into our equation. So we have our temperature equals B over L. B is this guy. Divided by L, which is this. So this is E minus 7. E minus 7 is 10 to the minus 7. So it's a little confusing. I really like, I'm going to copy this whole thing, in general for your homework, especially if you ever take a calculus class, I always recommend using this site called Wolfram Alpha. You maybe already know it. If you don't, it's awesome to know about. It can do tons of things for you. It can do your integrals. It can do your derivatives. It's also just like a calculator. That's great too. So we can paste this into here. I'm going to make sure to include my parentheses. Okay. Oh, and I got a negative number. Because this is not raised to the -3, it's minus. There we go. Cool. Wolfram Alpha is nice too because it displays your input really nicely so you can make sure you're actually calculating what you want to. So we got about 6,000 Kelvin. Does that seem reasonable? 6,000 Kelvin? Is that a reasonable star temperature? Yeah. If we got like 1 Kelvin, that would be a problem. That's roughly the temperature of empty space, so that would be bad. So we want to be in the thousands of Kelvin. Okay, so 6190.98. 6. Wait, is that right? Hello. 6190. Cool. So that is number 1. Any questions about how to do that? So that's what you're going to do for both of your stars. Hopefully it is really straightforward. Okay, going back to our PDF here. I'm only showing you one star, but you'll do this exact same process for the other star. Tell me which is hotter and which is colder. Easy enough. Number 3. Okay, so we need to figure out our classification for this star. So I'm going to search stellar classification. This is something that we talked a tiny bit about in one of our lectures, but I went through really fast. So again, Wikipedia is awesome. Let's see, I believe this, yes, okay. Okay, so now we can take our temperature that we calculated. So our temperature is 6190, and we can match it up to one of the temperature ranges here. So that is going to be this. So this is an F star that we found. So for clarity, oops. Okay, cool, easy enough. All right, so that's all we have to do for number 3. For number 4, so you just want to go back and figure out between the different stellar classifications. This is really straightforward because you're just matching based on temperature. But what you should say for this one is, like, let's say for instance your other star is an O star. So if star number 1 is an F star, star number 2 is an O star, you just want to say O stars are hotter than F stars. Done. Yes?
By any chance, can you show us what star this is?
Yeah, for sure. Yeah, so I picked one that was like a little incompatible with this thing because again it's old and it's a little glitchy. So the one that I switched to is HD 187282. Okay, and then 5, 6, and 7, you guys are on your own. For number 7, 7 is really easy. What you should do is you should make a little table that just has these 2 columns. So sorry, that didn't highlight well. But it just should have the class and the temperature columns. And then you can just assign new letters. You can make them fun, make it a fun little word. Make my life more fun when I'm grading your final projects. You can put a little like joke in, I don't know, whatever you want. Be creative. But this is like, number 7 is just a for fun question. So if you are just like totally out of steam end of the quarter and you want to just say like A, B, C, D, E, F, that's fine. Cool. Any questions about any of that?
Does this all have to be typed up, or?
It can be handwritten. Yeah, just make sure that your scans are like clear and everything. Yeah. Yes.
I don't understand the last question. You said, are we just rearranging the classes? Or?
Yeah, so the last question is just like create a new mnemonic. OBAFGKM is kind of weird. I don't actually know where it comes from, but it's just like come up with your own for fun. Yeah.
What did I say the answer was for number 4?
Number 4, you're comparing your stars.
Because I think she did.
Yeah, so the example I gave is like the star we looked at is an F star. If the other star you look at is an O star, you can just say O stars are hotter than F stars.
Oh.
Yeah.
What?
Okay, cool. So we're just gonna have a little working time now. I'll be up here if you want to ask questions. If you want to roll and enjoy your last day of classes doing other things than sitting in this lecture hall, that's great. Yeah, question.
So you said 5 through 7, and we have to answer this, right?
Exactly. Yeah. 5 through 7, you just have to answer once. Yes.
You want to see our work too, right?
Yeah. So I definitely want to see all your work. That's important, rather than just like putting down numbers. Definitely show your work. And again, for 5 and 6, I'm looking for short paragraphs. So like at least 4 sentences. Yeah.
We can just like find random stars, like whichever one we want.
Yeah, you can pick any on that list. So you're welcome to do the example that I showed for one of them. I feel like I'm kind of making your final project like too easy, but hopefully you guys appreciate that.
It's really complicated.
So yeah, so for one you can use that one, or you can pick two of your own. They can be any. I would not recommend picking one where the peak of the spectrum is all the way on one side or the other of the plot, because as you guys saw, those arrows get a little glitchy. Pick one to make your lives easier that the peak is in the middle.